Right. Hello, everybody. My name is Sebastian. I work in Montreal at the Montreal Neurological Institute. I also work at another research hospital in Montreal that focuses on mental health, the Douglas Mental Health Hospital. And I'm working here on problems of metadata, particularly metadata integration across different data sets so we can do interesting things with them. And if I understand the timeline correctly, this is the last or second to last talk. And so I was thinking I'm gonna do it relatively light and just want to convey a couple of core messages here and try to convince you that metadata are important. Okay, so let's just start with a question. It's a little bit contrived, but what makes data interesting? Well, if you look at these two images and I ask you if they're interesting, then you're obviously going to say that that's not a smart question because you don't know what you're looking at, right? This is you're missing the context. And you actually, there's a little bit of context that we have because the fact that we're actually looking at these pictures means that there's a file format and we understand what all the bits and bobs in the file mean, and so we can open them with tools. But that's obviously not what makes the data interesting. So there's something called metadata, and for the JPEG file format, that's part of the file. In an imaging file, let's assume you've all converted your data to bids. You might have something like this sidecar file, right? And there's information in there that's really important. For example, you can see what the scanner manufacturer was, or what was used to convert the image, and some information about sequences. And there are other files that contain other such important information. But you still don't really know what this is an image of. And similarly, on the left here, you can see all kinds of things. Some of them are actually interesting. You know, somebody used Photoshop on Windows, but we still don't know what the image is. So you kind of get where I'm going with this. Obviously, unless you're only interested in the properties of the images themselves, or if we're going back to the neuroscience context, if you know, if this is PhD comic, if you're not thinking of the brain as like a brain on a stick, then you probably want to know, well, what is the context of this image? And so if we look back at this image and I give you the context, you probably say this is an interesting image because this is a picture that was taken by a helicopter that flew on Mars. So that's pretty cool. Before you might have thought, this is just a bunch of rocks. Actually, you can see the helicopter here, and it took another picture of the rover that it came to Mars with. And so this is metadata. This is data about the data that we were looking at. And I would argue that this is what makes the whole picture relevant and important. And so here's an article where you can read all of the information that I was just telling you about. And similarly, if we look at this image and I tell you, well, this is an image from a data set of individuals with borderline personality disorder, and they did this task, and here is the patient. This is not the actual data. This is just a MRI image, and the table is from OpenNeuro. But now you think, okay, maybe this is a data set I'm interested in. Maybe I want to know this more about this data set. And again, this is metadata, arguably, so information about the data that we were looking at. Right, so just recap at this point very quickly, then we've already learned things, and I'm sure I think you already had a lecture on bids and all these things. So this is very important. You need to have standardized formats so we can have tools that consume them. We need to have our imaging metadata so we understand what was done to the image, and our analysis can pick up on this. And we also need to have context metadata. So for example, the file that I showed you on the left, this table, this could be a participants file where all this information is stored, or phenotypic information. And I would say that without all the metadata, the data are not very useful. I think you agree. Up to this point, I probably didn't say anything that's very controversial. You probably would not make a data set without a participant's TSV file. Okay, so let's put on a hat of the data provider and say, what do we want to do? Well, we have acquired a data set and it was hard and it costs a lot of money. And now we want to share it with other people. So maybe they will cite it, but hopefully so it's useful. And you go ahead, you take what you've just acquired and say, hey, my colleague, here's my data set. And it has all this great bits data. And here's my participant CSV file. And that's all you should need. And then your colleague comes back and say, well, what's a patient? And you realize, well, actually patient is only clear to me. I probably need to tell others what patient means. So you do something called a data dictionary, where you go through all of these variables and you give them human readable definitions, right? And here you say patient is somebody with a borderline personality type. And so we can add another thing that we need and say, well, we need data dictionaries. Those are really helpful and make the data much more usable. And now you go back and you say, hey, I have a data dictionary now. This should be all you need. And then your colleague comes back and say, well, what is borderline actually? Because I'm not really sure what you're talking about here. There's all kinds of ways of talking about borderline. And then you realize, well, there might be a misunderstanding about the definition. There might be different classification or diagnostic systems. And you said this is borderline, but maybe somebody needs a really precise understanding of how you arrived at this conclusion, if there was any, if you followed any criteria, right? And so rather than just say borderline, you should use a control term. So something that is not just a word that you came up with, but a definition that others agree with too. And so if we just quickly take a look at what control terms or vocabularies are, then very generally speaking, those are collections of words that we have an agreement on, and they can be organized in a certain way. So on the left there, we talk about mammals, so we have some idea of what mammals are, and then there's a hierarchy of them. They fall into different groups. If we talk about diagnoses, then maybe in your community, people use the ICD or they use the DSM. And then they have some type of agreement of what we mean if we use a certain word. And the neuroimaging community, there are also vocabularies like this, for example, the IDM terms where we say, okay, well, this is what we mean by an image contrast. This is what we mean by a T1 image, for example. And so now you have all these things, and that's really important. But there's some criteria for these vocabularies. So you notice how we keep adding things. They should be unique, because if two people say that something is autism, as we've seen, that is not unique enough, and if the definitions differ, then it's not enough to describe what you're referring to as autism, but you actually have to have some kind of identifier, and so what we're talking about here are globally and uniquely identifiable terms, and the way we can achieve this is by making the identifier of this term not, say, autism, but an actual URL, right, or URI. So this is like an address on the web, what you normally use to look up a website, and this is a unique identifier. If you go there, usually you get some information, and maybe it's a website, but at a minimum, it's a unique ID. So now you know exactly which of these two terms you were talking about. And because we are talking about things on the web here, another requirement that we have is that, well, these things should be machine readable, right? So now we're no longer saying autism and borderline, but we have URLs. Well, it would be nice if we can have machines consume this information and understand this and tell us about a data set or have some representation of this data set. So now we have quite the list here. And so we say, well, the file formats are important, imaging metadata is important, you need data dictionaries, control terms and vocabularies, and you need standards for machine readable metadata. And all of this is important to do good science, but probably somewhere along this list you said, like, yeah, okay, cool. You definitely, maybe I convince you, but maybe you're thinking, well, I have my participants CSV file and I'm okay. And to be honest, some of these things are tricky, and that's why at the end I will show you that there are tools to help you with this. But first, I want to do a little bit more of a motivation for why we actually need this. So why would we go and ask for this type of metadata? Why would we say, well, it has to be all these things? Well, let's put on a different hat, and in this case, we're putting on the hat of the data user. And so the data user, which often is the same person, just in a different context, you want to find some interesting data because you like to run an analysis, and it's not feasible to acquire all this data by yourself. And so you have a question. Let's say you want to find schizophrenic individuals. You want to look at diffusion imaging, and you care about their age, which is not a very unusual or complicated question even. But how do you answer that question? Well, usually you ask your lab mate, right? And maybe your lab mate is busy or they don't know. So it would be nice if you could ask a machine. As we've seen, it's not that easy to convey meaning, and the machine probably doesn't really understand what you're talking about. But what we could ask is, well, is there any context, something similar, where this actually works? Of course there is. So here, what I would just like to do here is just take the question, schizophrenic individuals with diffusion imaging, and we can think about, well, what is this similar to? Well, it's not so dissimilar from a question like this, right? Who has flights between Montreal and Berlin, and what is their price, right? Or maybe who has a recipe for poutine, and can I see a picture of what the end result looks like? And if you don't know what that is, go and Google it. You'll see a picture, and I'll explain in the meantime why you can see that. It's a great Canadian contribution to international cuisine. So the point of all this is you know who to ask for these things, right? And that's usually one of the big search engines. But the reason you can do that is because there's something called schema.org, which is a controlled vocabulary for metadata on the internet. So let's take a quick look at how this works. So now you have your data provider hat on again, but you're a travel agency and you have a flight between Montreal and Berlin. By the way, this flight does not exist. If it did, please tell me. It would be great. But anyway, you have this flight and you want to sell it. And so you put it on your website and you say, hello, I have this flight. And then friendly Google crawler comes by, looks at this, says, I don't know what that is, doesn't index, and nobody sees your flight, nobody buys it, you don't get any money. And so, very short story here, out of the goodness of their heart, obviously not, the search engines came up with a format for metadata and said, well, if you run a website or any kind of web-facing service, and you want us to incorporate your things into our search results, then please use a machine-readable format for these metadata, and then we will be able to parse them. And specifically, please use this vocabulary schema.org. So how did schema.org come about? Well, it's not out of the goodness of their heart. Actually, there's, as you know, strong competition between all these search providers, and they wanted to kind of differentiate themselves by doing new and interesting things, like, for example, showing the picture of the recipe at the top of the search results. But they realized that the only way to achieve this is by working together collaboratively, which I'm sure is not common for them, because there was such a chaos of formats and vocabularies that search domain owners, webmasters, didn't really know what to do, and in the end, kind of mostly also shrugged and said, yeah, okay, sure, you want this, but it's too complicated, or I don't understand. So they got together and they created schema.org, which is a vocabulary, and you can go and look it up, schema.org. It is a vocabulary expressed in a machine-readable standard called RDF. I'm not going to tell you what RDF is, but it's usually what's the structure of all these web metadata, link data things that ties it all together. And so I'm also only showing you a tiny subset here. Initially, they didn't have that many things. They focused just on some core terms that they were interested in. But you have many, many things and also relationships between things that you can annotate and put on your website. And so if you're the travel agency, then you go and look at the term for flight, and you see that a flight can have certain properties. This is not the entire list. And you go and annotate them. Maybe you would say, here's the flight number, and I don't know, departure airport would be Montreal, and then arrival airport Berlin, or something like that. And then you add this information to your website, but not on the part that is visible. You just add it in the code. And I'll just show you in a second what that looks like. But essentially, now that the Google Spider comes by, reads the metadata, the structured metadata in schema.org annotation, and understands, oh, okay, this website is about some flight, and there's some details here, so let's put that in my big collection of facts, and this big collection of facts, also known as the Google Knowledge Graph. And so what does Google do with this and on all these other search providers? Well, they offer you services, and those are the services that you're consuming as the data search hat, right? So there's Google Flights. You see these recipes for poutine, and there are all other kinds of things that you can do. But the important thing here is Google does not have the flight, right? The information stays on this website, and whoever owns the right to sell you this flight will continue to own this. So Google doesn't just grab everything and put it in a little box. They just take the metadata and put it in the Google Knowledge Graph. And if you're interested in this, then you can look up more detail what that means. But now we can obviously ask, well, what about data sets? Because this is not so dissimilar from somebody who has a data provider hat on, saying, well, I have a data set on, let's say, schizophrenia, and then nobody knows about this data set, nobody finds it, nobody cites it, downloads it, and it's just a wasted effort in a way, right? So it's not about the money, hopefully, but it's about not being able to find people who use this data. And so yes, there's also a data set in schema.org. It's very limited, only has very few properties because, it just has to have a name essentially and a license, or maybe not even, I don't think it even has to have a license. And so what you do is you take your data set, you put it on Zenodo, and then not really you, but Zenodo takes the information you provided, turns it into schema.org, puts it on the website, and then Google comes and takes it just like the flight. And if you look at this, so this is a data set. It's from a Montreal University, and it's on Zenodo. One thing to pay attention to is this is restricted access. You can't just go and download this. The data isn't free or open, and well, it's free, but it's not open in the sense that we often think about it. But if we go and inspect the website with schema.org, we can see that this is what the Google Spider parsed out of this page, right? So there's this a date published and a description and some other information. And this here on the left is actually what the website HTML, the JavaScript looks like. Or in this case, it's the JSON that is the JSON LD or the RDF representation of the schema.org terms. So you don't need to read all this, but I'm just trying to show you that there's actually, if you go and open the developer console on this web page from Zenodo, you will see this. And this is how Google becomes aware of it. And so why is this interesting? Well, because Google, among its other services, has something called Google Dataset Search. And if you haven't heard about this yet, it is an interesting service because you can just go and search things and it will return the data sets that it knows about. And so if you search for Perform Center or something that triggers this result, you can actually see, well, you get back this data set, even though, importantly, this is not an open data set, right? So it doesn't matter that you can't get the data. You can get the metadata, and that's what matters. The downside is that there's not a lot of detail. So you have a name and a description usually. And most researchers like details, and often what we are interested in are details at the level of the individual, right? So we don't, it's nice to know that there's a data set and maybe it's about schizophrenia, but we really want to know about individual people and what their properties or values are. So there's another thing I want to quickly tell you about, because I think it's a really cool initiative, and that's called the OMOP, or Observational Medical Outcomes Partnership. And so this came about for very interesting reasons. So there was a drug by Merck called Vioxx, and I think it was a painkiller. Oh yeah, there, it said painkiller. And so it went through all the drug trials that drugs have to go through, and was found safe and useful, and so was approved. And then later people found out, well, it increased stroke risk in a subpopulation of individuals. And so this is not too uncommon, but the problem here was that Merck was alleged to have known this information and suppressed for mysterious reasons. Why would they do that? But the results of this scandal were twofold. One was somewhat more usual. There was a big lawsuit, and Merck had to settle for several billions. Yeah, maybe more than they gained from selling the drug. But the other more interesting or relevant thing for our purposes is that there was an actual hearing in the United States Congress. And so the United States Congress went to the US Food and Drug Administration, who was in charge of making sure that drugs are safe, and say, hey, why did you not catch the fact that this drug wasn't safe? And the FDA said, well, clinical trials are too small because they're expensive. We can't run them for years and years until we find these potentially rare effects, because even though there was this huge scandal, the drug was mostly safe for most people. So the FDA said, well, sorry, we can't catch all of this in advance. We just don't have enough data. And because the person asking was the United States Congress, they passed a law and said, well, why don't you go and get all that data and figure this out, because we tell you to. And so they did that and passed the law. And there's a long story here, but the short answer of it is that the FDA got together with a number of pharmaceutical companies and the pharma lobby organization that is called Pharma, and basically said, okay, well, how can we make sure that all the data that everybody has, like hospitals, insurance companies, the pharmaceutical companies themselves, doctors, pharmacies, how can we bring this all together in order to get a big picture of population level health outcomes? And so they did two things. First, they came up with a data model, so an overview of a model of the world, so to say, but a really, really detailed one. So they wanted to capture everything that can happen to a patient in a clinical context. So that's what it's called, deep information. And they said, okay, well, now let's take all our data that everybody has and represent it in this way. So it's structured the same way. And it's a little bit like, I guess, the idea behind BIDS. So to have the same representation of the data, the same structure and organization. The other thing they did is, well, let's annotate the data with standardized terms or standardized vocabularies. And the reason for this is obviously that by the time where that I'm talking about now, this whole enterprise had grown quite a considerable bit and involved people or contributors of data from a number of regions in the world even. And so the problem was that not everybody has the same local regulations, and you know, like somebody uses this diagnostic system, somebody else uses another diagnostic system, different terms for different drugs, and so on. So they wanted to overcome this, and they said, okay, if you have a patient, and the patient, let's say, has a diagnosis, they can have many things, but let's say they have some condition, then here is a list of acceptable terms for diagnosis, and anything else is not allowed. And acceptable list of diagnostic terms that they chose is SNOMED CT. And that is a very large and developed over decades ontology of clinical terms for not only diagnoses and conditions, but also for just events. I think there's one thing in there that is bitten by a goose or something. So if you go to a doctor because you were bitten by a goose, then SNOMED CT has a term for this. And you'll notice that not only are there all these terms, but they also have relationships, and there's a number of other statements in this that actually make certain constraints on what properties and things can be related. So this is a really complex set of terms. It's not just a vocabulary, it's an ontology. But if we say, well, we have somebody here who has Parkinson's, we can see, okay, well, Parkinson's, there's a term for this, but then there are also these related superset terms, and this is a really useful property of vocabularies like this, because you could imagine coming at this a data annotated with such a vocabulary saying, I want to know everything about people who have Parkinson's, and then you find people who have this label. But you could also say, I want to have information on everybody who has any disorder of the central nervous system. This is likely covered here. And then you could capture the fact that Parkinson is also a disorder of the central nervous system and have this returned as a result. In any case, this is what they did. They said, everybody, regardless of what you're using locally to annotate your clinical diagnoses, we have to find some mapping into SNOMED CT. So this is now our shared vocabulary for things like clinical diagnoses. And then there are other vocabularies for other things like drugs and so on. And again, this is a bit similar to what we've seen with schema.org. Sorry. Now, again, the really important thing to keep in mind here is we're only talking about the metadata. So all of these hospitals will not give away their data. They have some server, and the data on the server is in a certain format, and it's very detailed because it's a hospital. I mean, hopefully, usually, but the data will always stay there. They will never share this data with OMOP or anybody else, but they can share the metadata about they can share some of they can organize their metadata in a format that they can answer requests coming from the outside. That's what I wanted to say. So you can write a query for SNOMED CT terms, and each of these hospitals can answer that query because they have the mappings to this common vocabulary. And I want to stress this point just to make clear again that if you're talking about these kinds of integrations to center, it doesn't necessarily mean that data has to leave the place where it is currently stored, or somebody has to gobble up all the data and keep it in a single location. And so this is now an initiative no longer run by the pharma industry, but actually by academia. It's a very successful open science project, and with many people contributing from all over the world. And so you might ask yourself, well, that's nice, but what can we do with this? Well, you can do things like this, and I think that's really cool. So if you've probably heard in the beginning of the vaccines, or sometimes still now, people have all these concerns about vaccine safety. So a lot of the adverse effects are extremely rare. So you need huge sample sizes to even detect them. But with something like OMOP, you can do that, right? And so you get into the territory where your sample sizes start looking like phone numbers. So they had 126 million people that they, I don't know exactly what this drug was. I think it was the AstraZeneca one. But they could rely on data from all of these healthcare systems to assemble such a big cohort and check, are there rare events that we should be seeing. Okay, so now I hope that I have convinced you a little bit more of the fact that these things are useful. And just to reiterate here, we need our shared file formats, the data organization, and imaging metadata. But the context metadata is usually what really makes this interesting and relevant. And so what I would like to encourage you to do is to really pay attention and spend time on it. So to see the metadata that you're providing as part of your research output, because that's what makes the research useful if you've already checked the other boxes. We've seen that controlled vocabularies are really important to have unambiguous definitions of the terms that we're using, and not only that, but also in combination with standardized machine readable ways of representing this metadata, they allow us to do cool things, provide services that would not be otherwise possible. So we would not be able to parse your tabular data and look at all of these strings in there and understand what they mean. Google and other search engines can actually do that, so that's why schema.org is not super prescriptive, but this is not usually feasible in open science academic context. And the last thing I want to say also here is it's really important. The data do not have to be open, right? And the metadata do not. They can be anonymized. The important thing is that you're following these principles in describing your data, so that we can so they can be found, they can be reused, and they can be connected. And so I'm sure you've already noticed there's a lot of what I'm saying are essentially the FAIR principles, and you've probably seen them. I'm not going to go over too much detail here, but that's kind of the thing that we need to click data together after you have after you've collected or published them and make them useful to others. So the thing I haven't talked a lot about yet is how you can actually do this, and I'm just going to spend a little bit of the remainder of the talk mentioning these things, and then I'll give you a short demo. And I'm not sure how I am for time, but I think I might finish even a little early. So the first thing, I'm sure you've already seen, how do you get to your bits data set? Well, there are tools for this, for example, DutyConf, and whether you have, if you have imaging data, for example, in a DICOM format coming off the scanner, right, you can use DutyConf. If you're a research institute, there's also from the ReproNim ecosystem, ReproIn, which is trying to organize the whole imaging pipeline, so you end up with not only bits from the scanner, but I think this also turns into a data set. So there are tools for this, essentially, is the bottom line. Now, you've got bits. How do you get a data dictionary? Well, data dictionaries, if you're just doing them for human consumers, and if that is, I think, already a pretty good step to do, that is very important, can take almost any format. Bits is a little bit more prescriptive, and they tell you, okay, well, it has to be a JSON file, it has to have, you know, certain keys and values, but there are a lot of good guides out there on how to do this. So, you know, there's the Turing way. I think this was already mentioned before, is a great repository that explains how to do research data management tasks and best practices. OSF has some guidance also on how to make data dictionaries. You can look in the bits specifications on what bits is expecting for you to do, and then at the end of the day, if you're doing such a data dictionary and you're just going to upload it to OpenEuro, then if it's not a very big data set, you might even just go in a text file and create this text editor and create this file and upload it as part of your data set. Now, in the process of creating this data dictionary, you hopefully realize that, okay, well, I should probably be more descriptive than just saying, okay, well, the value 1 in my diagnosis column means autism. And instead you should say, well, with autism, I mean the term from this vocabulary with the definition that is attached and the unique identifier. And so you might wonder, well, where can I find these things, right? Maybe you haven't really, or probably you haven't really encountered these kinds of vocabularies. And so there are almost search engines for these things. So there's a bioportal is a big repository of vocabularies and controlled terms. There's Intellex, that's also from folks working in the Reproducible environment, that is showing you where terms overlap from different vocabularies. In the imaging world, you have the NIDM terms, so for things relating to neuroimaging. This is a good vocabulary to use for annotating data relating to that. I would also encourage you to talk to your local librarians. That's essentially what they train in, and often have really good answers. But there is another answer here, and I think that's the more realistic answer, which is usually you will not be doing that completely from scratch. So either your community has expectations of controlled terms that are being used and the definitions attached to them, or at the point where you're going to share your data and on one of these platforms, there will be tools to assist you to provide metadata about your data set. And then these data repository providers are usually the ones translating this form that you've created into some vocabulary. Now, the important thing to remember here is that doesn't really replace the data dictionary, because most of these are at the data set level. So here you would get something like what we see with Zenodo, but more detail. But usually you get data set level descriptions here. And often what is really important for people to understand is the information at the individual level. Now, to get to that, we have tools, and I want to end on briefly mentioning these. So if you have, for example, participants TSV file, and you want to annotate the columns in it, so you want to explain, well, sometimes maybe it's not a very human readable variable here, maybe it wouldn't say age. So these are the columns from the participants TSV file. Then there's this tool here from the NIDM community where you can go in and you add these properties, and then you can search for a term from a controlled vocabulary that matches your description, and it will get attached to this term, and you can generate a data dictionary from this that will include the term definition. So this is where I get to the point where I'm talking about my own work, or our own work. I'm working in a team at the MNI, so with Jonathan Rosa, Nikhil Bhagwat, and JB. I think you might have seen that yesterday. And so we're also working on tools to make this easier. This is still relatively early development for the annotation tool, but here the idea is similar. We give you a way to tell us in your participants.tsv file what each of the columns refer to, and we're not we're being relatively limited here. We're just from now interested in age, sex, diagnosis, and assessment tools. And then once you've told us this, we will ask you to give us either precise definitions from terms in a controlled vocabulary that we're choosing, so you don't have to find that, or to transform these values. So I don't know, if you've seen age in the wild in a spreadsheet, you probably noticed that there are 1,000,001 formats of writing just a simple age, and then you're still missing the units. So there are all kinds of things that need to be harmonized there. And so what we can do once we have this is we can actually also provide some kind of a service here, and that is we can search at the individual level across different data sets. So if you upload your data on OpenNeuro and you filled out the OpenNeuro metadata form, then OpenNeuro has a really good search interface where you can search through that metadata. And they've recently upgraded it and asked for more detailed metadata. And so you will find data sets on OpenNeuro, and there are many, but you don't. I don't think there's yet a clean way of getting down to the individual level because these harmonizations aren't happening there. But something that would be really tricky to do is to say, well, is there any data on OpenNeuro that fits my criteria, and also on some other data sets? So we're currently working on Parkinson problems. So there's Parkinson data set and Quebec Parkinson data set. But you could imagine that any data provider who has internally this metadata information could expose it for this kind of integration. And so on top we can build like a little query tool and say, well, I want to know about individuals that have certain values in these different domains. And then I can query them. And I'm just going to show you very briefly how that works. So this is a little tool. And oh, I'm sorry, what I should have mentioned here is, so again, data stays where it is, right? So in order to run our tool, what we did is went to OpenNeuro and these other data providers and asked them for the metadata that they have about data sets in their database. And integrated that in our little knowledge graph. So kind of copycat with what we've seen with the Google thing, just at a obviously tiny scale. And so now we can ask this graph questions. And so if I just don't ask any questions and just say, show me what you've got, then at the moment we have 10,000 subjects, and they're coming from all of these different data sets. And this is something you can get with any data set level search, but now I can obviously go and have additional requirements that only exist at the individual level. So I can choose here. By the way, these terms you're obviously not gonna recognize, but they're coming from this NoMedCT vocabulary. So we're using these terms to harmonize our data. And now you can see if I have people, let's make it more realistic here. People above 60 who have Parkinson, and then let's say maybe they should be female, right? Okay, so there are not that many anymore. Now we have six data sets, 285 subjects. And now this might be something that you're interested in. Maybe you're planning a study. Now, if this data is not available or openly available, then at least you're aware that the data set exists, and you can go and talk to whoever has the rights to this data set, and maybe start a collaboration with them. If it is available, again, this is somewhat in development. We can give you ways of accessing what we know about the data, but there are obviously plans on making the data access itself programmatic. And so I think what you've just seen with Adina's talk about data-led could give you an idea of how OpenNeuro also already does that, gives you access to the data that they have via data-led. So you don't have to go and find the download button for all of the results from this cohort definition query. And so what I would like to say on this slide is that, as with all of these projects, this is obviously hugely embedded in a network of other projects, and we're closely collaborating with a number of these initiatives, particularly IDM and folks from Reproducible, and trying to find a way of essentially going back to that slide in the beginning where you could ask either your lab mate or a little bot about such a data set. So trying to see if we can find a way for you to ask such an individual level question, cohort definition question, to a bot or a service. And what I would just like to end on is that I want to encourage you to remember that when you have the data provider hat on and you're thinking about sharing your data set, then sometimes maybe you didn't, maybe you're under some time pressure. Maybe the journal doesn't really require all of these things. Although, by the way, that is changing. There are a number of policy requirements coming very soon about sharing your metadata and doing it in a fair way and so on. But still, I want you to keep in mind that the data that you're sharing and the metadata are a thing that needs to go together, and the detail and the unambiguity and clarity of your metadata are really what will give your data the maximum reuse value.